Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 532. K different pairs in an array. So given an array of integer nums and an integer k, return the number of unique k different pair in the array. Okay, a k different pair is an integer pair nums of I and nums of j where the following are true. What are the conditions? The first condition is I and j should be inside the range of 0 to the given array length. The second condition is no two indices. These two indices should not be same. Okay. Then the third condition is absolute difference of these values should be equal to k. Okay. For example, if I take this array 3, 1, 4, 1, 5, here the difference is what? 2. Which means I want to tell you what are all the different indices or what are all the unique pairs that has the absolute difference of 2. For example, I can tell you that 3, 1 or 1, 3, this is going to be one pair. Yes, and 5, 3 is going to be another pair because their absolute difference is going to be 2. Now you may ask, hey, here 3, 1, it is going to be one pair. You also take this 3 and this 1. Okay, this is going to be another pair. No. They are asking that it should be unique. Okay, so you cannot take that. So how many unique pairs are there? 2 pairs. Okay, for example, here the second example, 1, 2, 3, 4, 5. Here k is equal to 1, which means I will be telling that 1, 2 is going to be one pair, 2, 3, then 3, 4, then 4, 5. So there are totally 4 unique pairs available. Okay. Now see here 1, 3, 1, 5, 4. Here k value is what? 0. K value is 0. So you may tell I take this 4 and again this same index. No, you cannot take that. They have clearly stated in the question itself. Okay. So I can tell you that this 1 and this 1 will be forming a unique pair that yields an absolute difference of 0. Can you understand this? Okay, so this is what the problem statement is. Now tell me how we are going to solving this at first. Always first try the brute force approach. Okay, so what is the brute force approach? The brute force approach is take all possible combinations and check whether it yields an absolute difference of 2 and push them into a set data structure, so that you will be only getting the unique values inside the set data structure. At last, just return the length of the set data structure. What I am telling is, first of all, I will be starting from this 3. Okay, and again I will be starting from this 1 for this particular 3, this particular index. Now, whether 3, 1 yields me the absolute difference of 2. Yes. Whenever it is yes, just push into the set data structure like 3, 1. Okay, you may push in it like a string, or you may push it inside like a pair data structure, data type also. That's your wish, absolutely. Okay, now let's just understand the logic behind it. Afterwards, we will be solving in terms of code. Okay, now just go here 3, 4, no, because it yields the absolute difference of 1. Now again 3, 1 yields the absolute difference, but we should not add this, right? If I add it also, the set will be maintaining me a unique values. It don't allow a duplicate values. That's why I am using a set data structure. Okay. Now 3, 5. Yes, 3, 5 will be yielding a absolute difference of 2. Okay. Put 3, 5. Understood? Now again make this yellow pointer to move here and again go to its right side values. So 1, 4, what is its absolute difference? It is 3. No. 1, 1, 0. No. 5, 1, which is equal to 4. It is not the absolute difference we need. Okay, fine. Now again move my yellow pointer to next value. Okay, now first I will be taking this 1. So 4, 1, no. 4, 5, no. Okay, make my pointer to move here. Now 1, 5, no. It won't yield the absolute differences 2. Fine. So now what is the length of the set? It is only 2. So 2 is going to be my output. Yes. Now tell me what is the time complexity? So I can tell you the time complexity will be O of n square, because for each and every values we are going to traverse all other values, which means for one value it will be n. For n values it will be n into n, which is equal to n square, and we are just making this to put inside the set data structure, right? So in worst scenario it will be log n. Now tell me what is the space complexity? It will be O of n, right? Fine. So this is going to be your first approach. So whether we can just optimize this first approach and give a better approach, which is going to be time efficient than this. Okay, see here what is the searching algorithm we are using? Here we are using a linear search algorithm. That's why we are getting what? N square. If I tried the binary search algorithm, then what is the time complexity we are getting here? It will be n log n. Okay, so now just go and try the binary search algorithm. So this is the example, right? Now I will be first sorting this to implement the binary search algorithm, as you know. So 1, 1, 3, 4, 5. Now to understand this logic, you should be clear with the binary search. If you don't know about the binary search, I will be giving that binary search link in the description. Just go and watch that video once, then continue this, so that you can understand this clearly. Okay, fine. Now here 0, 1, 2, 3, 4. So these are all the indices. Now I'm going to do the same method I have done in the previous, okay, but the only difference I'm going to use the binary search. Like, first of all, I'm standing here 1. Okay, now what is the target we want? It is 2. It is 2, right? Okay, here is 1, and we know it is in a sorted order. It is in a sorted order, which means all things in a right side will be greater than this, which means if I want a minus b, which is equal to 2, like this, then I can tell you a is equal to 2 plus b, which means for this 1 I need 2 plus 1, which is equal to 3 in its right side. If there is 3 exists, then I will be just push into the stack. Okay, so here is a stack. Now I will be doing a binary search on these all 4 elements. Okay, which means the starting index, the lower bound will be 1 and the upper bound will be 4. Okay, now I will be just searching whether this 3 is there or not. Yes, it is there, right? So push into my stack data, hash set data structure. Okay, now move on to the next thing. So it is 1 again. Okay, now I'll be checking for these 3 values alone. Again, for what? 1 plus 2 is equal to 3. So whether 3 is there in these limits, 2 from second index up to 4th index. Yes, there is 3. So again push it. When I'm pushing it, it don't allow the duplicate, right? So it won't allow the 1, 3 again. Okay, now go to the next thing. So 3 means we want 3 plus 2 is equal to 5. Whether 5 is in its right side, we are going to use a binary search for these 2 elements. Yes, it is there. Then I can tell you that 3, 5 is added, right? So next thing is 4. So 4 plus 2 is equal to 6. 6 is we required, but whether 6 is there? No, 5 is only there, right? So I cannot include that into the set, and that's it. Finish there. So I can tell you that what is the answer? It is 2 is my output. Okay, now what is the time complexity? It will be O of n log n. First of all, we are sorting, right? For sorting in a merge sort algorithm, it will be n log n plus. What is the next thing we are doing? We are just taking one element and doing a binary search on rest of these elements, which means we are taking n elements and doing a binary search on those n elements. Okay, and we are just including that into the set data structure, which means log n. So overall, the time complexity will be O of n log n into n log n. Okay, now what is space complexity? It will be O of n for merge sort algorithm plus again n for using this set data structure. So this is going to be your time and space complexity analysis for this better approach. Now I may ask you, right, whether this set is mandatory or not, because For me, this set is not mandatory. Okay, why I'm telling this? So we are getting into a optimized approach. Just listen this carefully. You can understand how we are going to use a logic that going to be implementing this solution without using the set data structure. So let me take the example. So this is the example. Now for this also, first step is going to be, we are going to sort it. The only difference is we are going to add one line that makes me this set free in my solution. So let us sort it. So after sorting it, it will be like this. Okay. Now I'm going to use the same algorithm. Like I'll be standing here and searching whether there is anything here which is equal to 1 plus the target k. So let us take k is equal to 2. Then I'll be checking 1 plus 2 which is equal to 3, whether 3 is present in its right side or not. Right side or not, right? So let me take this. Just a minute. K is equal to 2. Now 1 plus 2 which is equal to 3. Whether 3 is there in here. Yes, it is there. Then what we are going to do? We are going to take my result initially as 0. Now my result will be going to be 1. Result will be going to be 1. Now in next step, I will be going here. Now again it is 1. Now it is in a sorted order, right? If it is in sorted order, I want to check whether the previous element is equal to the current element. If it is so, doing this again a binary search will lead to the same answer, right? I don't want to do that. So skip. So what is the one line I am going to add? Whenever I am going to the new element, I am going to check whether my previous element is same or not. So here 0, 1, 2, 3, 4. Whenever I am standing at the 0th index, I don't want to check. Whenever I am not standing in the 0th index, I want to check whether my previous element is the same element or not. If it is same element, I already included that in my answer, right? Apart from this, everything will be same. So now again for 1, it will be skipped. It will be skipped because its previous value is same. So now 3. So for 3, again, I will be doing a binary search on its right side. And what is the value now? It will be 3 plus 2 is equal to 5. 5 is there. So I will be making my result to 2. Now I will be going to here. So 4 is not equal to 3. Again, I am doing for 4. For 4, there is nothing because 4 plus 2 is equal to 6. So 6 is not there in its right side. So I will be stopping here. So what is the result? It is 2. Can you understand this? How one line can save the time complexity in a vast manner. So now tell me, what is the time complexity? So time complexity will be O of n log n for sorting and plus, and we are doing n log n for binary search. So overall the time complexity will be n log n, O of n log n. Okay, and what is space complexity? It will be O of n because we are using a merge sort algorithm. For merge sort algorithm, it also take a auxiliary space. Fine. Okay, so this is what the 3 approaches. Now let us see the code for all 3 approaches. Yes, so see here. First of all, the brute force approach. Okay, in brute force approach, I will be taking a set that containing the string inside it, and then I am taking the n as a number of elements in the nums. Now I will be traversing from 0 up to n. Okay, for I, and for j, I will be taking I plus 1 up to n, which means i's right side values. Okay, all the right side values of I will be taken in parts of j. Now I am using a condition here. If the absolute difference of that ith element and the jth element is equal to k, then what should I do? I will be taking the minimum. I will be taking the minimum first on these 2 values and taking that as a, and maximum as b, and adding as a plus b as a string. A plus b as a string. Can you understand this? This is the reason why I told in this drawing explanation itself. If you are using a Python, again, Python and C++ code are given in the description. Just go and watch it. Okay. If you are using a Python, you may use tuple directly. Okay. If you are using a set data structure, you may use pair data type. Sorry. If you are using C++, you may use pair data type. Right. Here I am using a string data type. For string data type, I will be taking the minimum value first, then doing a comma, and I am adding the maximum value, concatenating all these and just adding that into the set. Can you understand this? Okay. Now at last I'll be returning the set size. That's it. So this is going to be your overall brute force approach. Now let us see the binary search approach. So see here. So here I didn't mention the binary search approach by using the set data structure. Just try that by yourself. If you cannot, just comment below. I'll be giving that solution in the comment section. Okay. So see here. First of all, I am going to. So this is the optimized code. This is the optimized code. Okay. Without using the set data structure. So see here. First of all, I am just sorting the array. Okay. Now count will be equal to 0. Now I will be traversing from 0 up to the length. Okay. Here you may also put up to length minus 1 also. That's your wish. Okay. Because for last element, we don't have any right side part. Okay. So here if you put like minus 1, it is also okay. Fine. Okay. Now here I'm using a condition like if I is greater than 0, which means I is not under, the I is not pointing to 0. If it is pointing to 0, it doesn't have any previous elements, right? So the I is strictly greater than 0, and also my nums of I is equal to its previous value. Then what should I do? I will be continuing it to avoid the duplication. So this line is so much important. It is also useful when you are going for a recursion and backtracking. Okay, there they will be asking you to find unique subset or unique permutation. That this line will be so much useful. Okay, so always remember this line, this logic. Fine. Now target is equal to nums of I plus k. You may ask, we also have nums of I minus k because we are taking absolute difference. Okay. So, but here we have sorted the array first. If we have sorted the array first, I can tell you that whichever element for that particular element, all the right side element will be greater than that. So greater means we want to put the plus symbol. If you know about the modulus property, you can understand this. Okay, now left is equal to I plus 1 and right is equal to the last index. Okay, now I am doing a basic binary search approach here. If there is a target, then I will be doing a count plus plus the resultant variable, and I will be breaking that loop. Okay, else where should I go? I just implemented that. So this is entirely a binary search approach. If you understand the binary search, you can understand this also. Now at last return the count. That's it. So this is going to be the optimized approach, and here we didn't use any set data structure. In your interview point of view, the technical interviews, they will be giving this question and they will be telling you the constraint. You should not use a set data structure or the hash map data structure. Okay, now how you are going to do? Now you want to understand this logic so that you can implement a unique pairs. Okay, fine. So this is what the entire solution. And if you really like this video, subscribe to my channel. And if you want to know about these kinds of algorithms, just go and search in my YouTube channel. And if you have any doubts, just comment below. I'll be commenting out the answer. Thank you.